Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. For lesson 2 today, I will continue with chapter 2, kinematics of linear motion. The first one, linear motion 2.1b. Next, 2.2, uniformly accelerated motion. And the last part I will continue is 2.3, projectile motion. Subtopic 2.1b, a physical meaning of ST, VT and AT graph. How do you relate between S, displacement, velocity, and acceleration by graph? First, when you have a displacement against time graph, how can you get velocity from displacement against time graph? So what do you have to do is, displacement against time graph, you can get the velocity by calculating the gradient. The gradient of ST graph will give you velocity. Velocity against time graph, the gradient of velocity against time graph will give you acceleration. The gradient of velocity against time graph will give you acceleration. Example, so you have velocity against time graph, okay, a straight line graph. So basically this gradient, the value of this gradient will give you acceleration. Next, acceleration against time graph. How do you get velocity from it? Acceleration against time graph, you can calculate what is the velocity of the motion by calculating the area under the graph. You can get velocity by calculating the area under the graph. From velocity against time, you can get displacement by calculating the area under the graph. Okay, so basically you have two methods. From displacement to velocity to acceleration is gradient. Then from acceleration to velocity, velocity to displacement is area under the graph. Example, here you have acceleration against time. Then, okay, let's say this is your graph. So how do you calculate the velocity of the motion? You just have to calculate what is the area under the graph. This value here will give you your velocity. Let me show you the example on how to apply those concepts before. All the calculations will be done in your tutorial class. First, example, a car moves at constant speed. Graph of displacement against time, you will get like this. Example, after the car has traveled for 10 seconds, it has moved 5 meters positively. Then, after 20 seconds, it has moved 10 meters positively. So this is a directly proportional graph. As t increase, s increase. What about the gradient here? This is a straight directly proportional line. So the gradient is a constant gradient. So the gradient is a constant gradient. What is the displacement here? Displacement increase directly with time in positive direction. Okay. How can we transfer this information of S against T into velocity graph? Remember, to get velocity, you need to calculate what is S against T gradient. So based on this graph here, gradient of S against T is constant. So this constant indicates your velocity constant. Okay, velocity constant. velocity constant. I just sketch my graph here. Okay, just sketch my graph here because it doesn't involve any calculation yet. So, okay, constant velocity, just a horizontal line graph. Constant velocity. Velocity is constant in positive direction. What about acceleration? What about acceleration? Acceleration comes from gradient of velocity against time. What is the gradient here? Horizontal line doesn't have any gradient value. So, horizontal line will give you a zero gradient. Horizontal line will give you a zero gradient. Zero gradient in velocity against time indicates your acceleration acceleration is equals to zero. Okay, acceleration equals to zero. Transfer it into your acceleration against time. Basically, the line is just on the axis of the graph. This is your acceleration. Acceleration equals to 0 meter per second squared. Acceleration is 0. Second example. Example of a car speeds up. A car speeds up after 10 seconds. Okay, after 10 seconds, the car has moved for 5 meters. After 20 seconds, the car has moved for 20 meters. What is the difference between this graph and the previous one? Obviously, this time S against T is not directly proportional. Okay? This is gradient increase. The displacement increase exponentially with time in positive direction and rapidly increase as it approaches final position. How do we know it is a positive direction? Positive direction because it is plotted in a positive y-axis. It is plotted in a positive y-axis. What about the gradient? If we compare three different points on the graph, you can see as time increases, the gradient becomes steeper. Gradient becomes steeper. That indicates gradient increase. That indicates your gradient increase. Gradient for S against T increase. Gradient will give you velocity against time. Gradient increase means your V increase. Okay, we plot how to plot a V increase starting from 0. Then you just have a straight line graph over here. This is velocity increase. Okay, velocity increase. Straight line directly proportional. What is the gradient? What is the gradient? Directly proportional. Gradient is equals to constant. Constant gradient. Okay. Velocity increase directly with time in positive direction. Velocity increase directly with time in positive direction. Gradient of V against T is constant. Constant gradient. Gradient of V against T will give you acceleration. Constant gradient. So how to draw a constant gradient graph? Okay, because I'm sketched, so it doesn't matter where it is. But if it's involved calculation, then you have to take into account the value. So here, constant acceleration, a straight line horizontal graph. Okay, a straight horizontal line graph. Constant acceleration. Acceleration is constant in positive direction.